how similar or different are the brain areas controlling speech and language in, say, a songbird and a young human child?
Yeah. So going back to the 1950s, and even a little earlier, and Peter Mahler and others who got involved in neuroethology, the study of neurobiology of behavior in a natural way, right? They start to find that behaviorally, there are these species of birds like songbirds and parrots, and now we also know hummingbirds, just 3 of them out of the 40-something bird groups out there on the planet, orders, that they can imitate sounds like we do. And so that was the similarity. In other words, they had this kind of behavior that's more similar to us than chimpanzees have with us, or than chickens have with them, right? They're closer relatives. And then they discovered even more similarities, these critical periods, that if you remove a child, this unfortunately happens where a child is feral and is not raised with human and goes through their puberty phase of growth, it becomes hard for them to learn a language as an adult. So there's this critical period where you learn best. And even later on, when you're in regular society, it's hard to learn. Well, the birds undergo the same thing. And then it was discovered that if they become deaf, we humans become deaf, our speech starts to deteriorate without any kind of therapy. If a non-human primate or let's say a chicken becomes deaf, their vocalizations don't deteriorate, very little at least. Well, this happens in the vocal learning birds. So there were all these behavioral parallels that came along with a package. And then people looked into the brain, Fernando Nottebohm, my former PhD advisor, and began to discover the area X you talked about, the robust nucleus of the archipallium. And these brain pathways were not found in the species who couldn't imitate. So there was a parallel here. And then jumping many years later, I started to dig down into these brain circuits to discover that these brain circuits have parallel functions with the brain circuits for humans, even though they're by a different name like Broca's and laryngeal motor cortex. And most recently, we discovered not only the actual circuitry and the connectivity are similar, but the underlying genes that are expressed in these brain regions in a specialized way, different from the rest of the brain, are also similar between humans and songbirds and parrots. So all the way down to the genes, and now we're finding the specific mutations are also similar, not always identical, but similar, which indicates remarkable convergence for a so-called complex behavior in species separated by 300 million years from a common ancestor. And not only that, we are discovering that mutations in these genes that cause speech deficits in humans, like in FOXP2, if you put those same mutations or similar type of deficits in these vocal learning birds, you get similar deficits. So convergence of the behavior is associated with similar genetic disorders of the behavior.
Incredible. I have to ask, do hummingbirds sing or do they hum?
Hummingbirds hum with their wings and sing with their syrinx.
In a coordinated way?
In a coordinated way. There's some species of hummingbirds that actually will, Doug Ashler showed this, that will flap their wings and create a slapping sound with their wings that's in unison with their song. And you would not know it, but it sounds like a particular syllable in their songs, even though it's their wings and their voice at the same time.
Hummingbirds are clapping to their song.
Clapping with they're snapping their wings together in unison with the song to make it like, if I'm going ba-da-da-da-da, ba-da, and I banged on the table, except they make it almost sound like their voice with their wings.
Incredible.
Yes.
I'm.
And they got some of the smallest
I guess as the
brains
kids
around.
would say, mind blown.
Yes,
right?
yes.
Incredible.
Yes.
Incredible. I love hummingbirds, and I always feel like it's such a special thing to get a moment to see one because they move around so fast and they flit away so fast in these ballistic trajectories that when you get to see one stationary for a moment or even just hovering there, it's you feel like you're extracting so much from their little microcosm of life. But now I realize they're playing music essentially.
Right, exactly. And what's amazing about hummingbirds, and we're going to say vocal learning species in general, is that for whatever reason, they seem to evolve multiple complex traits. This idea that the evolving language, spoken language in particular, comes along with a set of specializations.
Incredible. Yeah. When I was coming up in neuroscience, I learned that, I think it was the work of Peter Marler, that young songbirds learn their tutor's song and learn it quite well, but that they could learn the song of another tutor. In other words, they could learn a different, and for the listeners, I'm doing air quotes here, a different language, a different bird song, different than their own species song, but never as well as they could learn their own natural, genetically linked song.
Yes.
Genetically linked, meaning that it would be like me being raised in a different culture, and that I would learn the other language, but not as well as I would have learned English. This is the idea.
Yes.
Is that true?
That is true. Yes, and that's what I learned growing up as well, and talked to Peter Mahler himself about before he passed. He used to call it the innate predisposition to learn. All right, so which would be kind of the equivalent in the linguistic community of universal grammar. There is something genetically influencing our vocal communication on top of what we learn culturally. And so there's this balance between the genetic control of speech or a song in these birds and the learned cultural control. And so yes, if you were to take, in this case, we actually tried this at Rockefeller later on, take a zebra finch and raise it with a canary, it would sing a song that was sort of like a hybrid in between. We call it a caninch, right? And vice versa for the canary, because there's something different about their vocal musculature or the circuitry in the brain. And with a zebrafinch, even with a closely related species, if you would take a zebrafinch young animal and in one cage next to it place its own species, adult male, right? And in the other cage place a Bengalese finch next to it, it would preferably learn the song from its own species neighbor. But if you remove its neighbor, it would learn that Bengalese finch very well.
Fantastic.
So it has something to do with also the social bonding with your own species.
Incredible. That raises a question that based on something I also heard, but don't have any scientific peer-reviewed publication to point to, which is this idea of pigeon, not the bird, but this idea of when multiple cultures and languages converge in a given geographic area, that the children of all the different native languages will come up with their own language. I think this was in island culture, maybe in Hawaii, called pidgin, which is sort of a hybrid of the various languages that their parents speak at home and that they themselves speak, and that somehow pidgin, again, not the bird, but a language called pidgin for reasons I don't know, harbors certain basic elements of all language. Is that true? Is that not true?
I would say I haven't studied enough myself in terms of pidgin specifically, but in terms of cultural evolution of language and hybridization between different cultures and so forth, even amongst birds with different dialects, and you bring them together. What is going on here is cultural evolution remarkably tracks genetic evolution. So if you bring people from two separate populations together that have been in their separate populations, evolutionarily at least, for hundreds of generations, so someone speaking Chinese, someone speaking English, and that child then's learning from both of them, yes, that child's going to be able to pick up and merge phonemes and words together in a way that an adult wouldn't. Because why? They're experiencing both languages at the same time during their critical period years in a way that adults would not be able to experience. And so you get a hybrid. And the lowest common denominator is going to be what they share. And so the phonemes that they've retained in each of their languages is what's going to be, I imagine, used the most.